Alright, hello everyone. So today we're going to talk a little bit about your atomic structure. So let's jump straight into the first page. Okay, so for the first part, we're going to talk about the atomic structure itself. How does an atom look like on the inside? So over here, you actually have the nucleus on the inside. So what you'll realize is inside the nucleus will be two subatomic particles. So you will have your protons and your neutrons. Surrounding it, what do we have? We will have your electron shells, and over here the crosses will actually represent the electrons. Alright, so over here on the next page, okay, there's a table that you will want to look at. So this will actually help you to summarize the three subatomic particles that you'll see inside your atom. So you have your protons, your neutrons, and your electrons. So if you pay attention to the columns, the first column that you will have is the mass column. So what mass does this represent? It represents the relative mass. So over here you'll see a unit and 1 unit. So what does this unit represent? This unit is actually a relative number. It doesn't represent 1 kg or 1 gram, right? So if protons and neutrons were to be apple and oranges, they will be apple and oranges of the same size. Okay, so that's what this actually means. On the other hand, okay, you'll realize that electrons is nearly 2000 times smaller. So what you can determine about the mass here is that it will actually be negligible mass. So it doesn't actually contribute to the mass of the atom. Okay, so over here, these two will contribute to the mass of the atom. Okay, so over here, one more thing that you need to note is the charge. So protons will always be positively charged and electrons will always be negatively charged. Okay, so where will you be able to find them? The protons and neutrons will be found in the nucleus, and then the electrons will be found in the orbitals, the electron orbits. So next, you actually look at the symbol of an element. Okay, so this is just an example of how your elements are actually being displayed sometimes. So if you actually pay attention to the periodic table, I like to focus on my favorite element. You can see sodium. So you'll see two numbers. You'll see 23 and 11. So different versions of the periodic table may actually display the information a little bit differently, but the numbers don't really change. Okay, so you'll always notice that apart from hydrogen, all elements will always have a bigger number and a smaller number as well. Okay, so the smaller number will always represent the proton number. Okay, and sometimes we actually call it the atomic number as well. Okay, so this number will tell you the number of protons only. On the other hand, the bigger number is sometimes what we like to call the mass number, or sometimes we like to call it the nucleon number. Okay, so what will this number tell us? It will be your total number of protons and neutrons. Okay, so this is because your protons and neutrons will actually contribute, right, to the mass of the atom. Okay, so this is just an example to show you how to read our symbols. Okay, so there are some things that you need to know. This is very important. So this is a very important characteristic of an atom. So when it comes to an atom, the number of electrons will always be equal to the number of protons. Okay, so always remember here, the number of electrons will always be equal to the number of protons. So electrons will be negatively charged, your protons will be positively charged. Okay, so if I have the same number of plus and minus charges, it will cancel out. Meaning, right, that your atom will always be electrostatically neutral. Alright, so other than that, you'll also notice, right, if you ever want to calculate the number of neutrons, you'll take the bigger number, which is the mass number, to subtract off the atomic number. Okay, so if you have no questions, okay, let's move on to the next part. Okay, we'll talk about electronic configuration. So when it comes to electronic configuration, we're going to talk about how electrons are actually being arranged in an atom. So you'll notice here in your first shell, you will always have 2 electrons, and in your subsequent shells, you will have 8 electrons. So you've actually noticed sometimes we write 18 electrons here, So just know that this is not tested, right? But we're just going to put it out there because sometimes once in a while they do come out with questions that have a little bit of database that actually suggests that there will be 18 electrons on the third and fourth shell. Okay, but for you guys, for you students, at least know that for these shells, right, you will always be 8 except for the first shell. Okay, so how are we going to fill up our shells? We will always fill up from the innermost shell until they are full before we move on to the subsequent ones. So if you look here, there's a quick example for you. So we have magnesium here, right? You see 12 and 24. So 12 is the proton number, and that will of course lead us to our number of electrons, which is also 12. Okay, so how are we going to arrange the electrons? In the first shell, we will have 2 electrons. On the second shell, we have 8, and the third shell, we have the last 2. So this is how we will represent our electronic configuration of 282. Okay, so that will be the first, second, and third shell. Okay, so if you have no questions, I'm going to get you guys to try it over here. Okay, so sodium will be 11, chlorine is 17, oxygen is 8, aluminium is 13, and then nitrogen will be 7. Okay, so at this point in time, you guys can actually let the students try out this question. Give them a couple of minutes, provide them with a periodic table before you move on from this part. Okay, so let me move on to the next part. So once the students are done, okay, this is the next part. Okay, students, so now back to the periodic table. There are some things that you need to learn about the periodic table. So the first thing is about the period, all right? So when it comes to the same period, okay, it actually means that the atoms are having the same number of electron shells. Okay, so anything here that is on the same period, which is your horizontal row, will have the same number of electron shells. Okay, so one more thing you need to know is your groups. So if anything is ever in the same group, it will mean that they have the same number of valence electron, which also affects their chemical properties. So what am I trying to tell you here is that electrons are responsible for your chemical property. Okay, so once you have noticed this, I have one more thing that I need you guys to notice. So over here, if you look at your periodic table, right, you'll realize that sodium, your hydrogen is number 1, helium is 2, lithium is 3, right, so on and so forth. So you actually notice that everything on your periodic table is actually arranged according to the atomic number. All right, so I repeat here is that your number of protons will always contribute, right, to the identity of that element. Okay, so just remember that. Okay, so moving on here, we're going to move on to the next part. We're going to talk about metals. Okay, so metals are generally on the left hand side, and then your non-metals are generally on your right hand side of the periodic table. Okay, so now, right, once you have reached this part, you can generally get the students to actually try out some questions. Okay, so I'll show you which questions you can get the students to try. So you can take a look at this page. So this is on page 13 of the document. Okay, so generally I'll give them a couple of questions that's related to atomic structure. So you can see I'll give them number 2, number 4, number 5, number 6. Okay, we also give them number 9, number 10, and number 11. Okay, the questions here are not meant to be hard. They're pretty simple. So you can just check on them once they're done. Okay, so I'll move back to the notes. Okay, so after they have done with the question, you're going to move on to the ions portion. Okay, so generally they'll take about 5 to 10 minutes to finish the previous MCQ. Okay, so now we're going to continue with ions. Okay, so now let's go back to ions. Okay, this is the next thing. So over here, your atoms will lose or gain electrons, okay, to actually attain your full valence shell, okay, to become ions. All right, so now, right, the important question is actually how do we determine the charge of any ion? Okay, so the first step is to always write out the electronic configuration. So for example, we have oxygen. Okay, oxygen is number 8. Okay, so you'll realize its configuration is 2.6. So now, right, the purpose is to actually gain your full valence shell. Okay, so there are two ways about it. You can either gain 2 electrons or you can lose 6 electrons. And of course, we will always choose the smaller number that we have. So in this case, we will actually choose the gaining of 2 electrons. Okay, so what we will realize at this point in time, okay, is that if you have gained electrons, your configuration will become 2.8. Okay, and since electrons are negative, right, this guy will actually become a negative ion. Okay, so when you gain electrons, okay, since electrons are negative, right, this atom will become a negative ion. All right, so just make sure you understand that electrons are always negative. So when we gain electrons, we will become negative. But if we lose electrons, the opposite will occur and we will become positive. Okay, so with that, okay, this part isn't really necessary. So you can get the students to go and straight away try some questions. Okay, so over here, I'm going to show you the questions that will circle in purple. So question 1. Okay, so the key point is to get them to know that this is on ions. Okay, then question 3 is also on an ion. Question 7 as well. Question 8 as well will also be for your ion. Okay, so once they have tried this couple of questions, okay, if you feel like the students are pretty fast, and they are able to do more questions, continue to test their understanding. You can give them question 12, 13, 14, 16, 19. Okay, so usually these are the few extra questions that I'll give them to occupy them a little bit if they are a little bit too fast. Okay, so make sure you check through their work, make sure they are okay before you continue from here. Again, okay, so usually at this point in time, do judge your students. If they are, they are very lost, you can always give them extra practice. I'll show you the questions that you can give them. But if not, they are pretty fast, you can continue on with the lessons. So I'll take it that the student is able to understand the concepts that are being taught here. So we will move on to the last part of this chapter, which is known as your isotopes. So let's go back to isotopes. Okay, students, so now we are back to isotopes. Isotopes, what are they? Okay, basically they are the same element with the same atomic number, but their mass number is very different. Okay, so essentially what am I trying to tell you is that isotopes will always have the same number of electrons and protons, but your isotopes will have varying number of neutrons. So it just means that their number of neutrons is different, but their protons are the same. Right, so if I can give you an analogy here, it's like, it's like being able to clone somebody, right? But this clone isn't entirely perfect. He might be a little bit fatter, he might be a little bit skinnier compared to the original person. Okay, so because of that, okay, isotopes, because of them having the same number of electrons and proton, they will have the same electronic configuration, which means they will form ions of the similar charges, and they will also have similar chemical properties. Okay, the one last thing I need you to know is that actually, although our chemical properties are the same, right, isotopes have varying physical properties. Okay, so once you have understood this, then we can try out a few questions on the next page. Okay, so over here, once the students are done, I'm going to circle some questions in blue that you can give them that's completely related just to isotopes. All right, so 15, 17, 18, 20, and 22 are some questions that you can let them try. Okay, so after these few questions that they have tried, you can occupy them with more questions to practice all 3 things that they have learned. So at this point in time, they have learned 3 things: one about the atoms, one about the ions, and some about the isotopes. So where you will want to focus on now will be the extra questions. Here are all the extra questions that I usually give them. So 26, 27, 28, 29, 30, 33, 34. Okay, then on the next page, 37 is a very important question. I will let you guys know why when we have a session. But basically the shape of this is extremely important. The answer here is B. There's actually another kind of question that's open-ended that guides the student to this answer. So just make sure that 37, the importance of it is actually showed to the student. Okay, then I also give them 38, 39, 40, 41, okay, 43, 45, okay, 46 is good as well, and that's usually when I stop. Okay, so usually I don't give them questions beyond this, but the questions that I've been giving you are really meant for guide, for the extra questions. Okay, but for the rest, those that I have circled in the different colors, the red, purple, and blue, those are the questions that are fixed. Okay, but the questions that I highlighted are questions that are a little bit more extra. Okay, it's up to the discretion of the tutor, but of course for a start you guys can follow what we have shown you. Okay, so let me know how it goes. Reach out to me if you guys have any help. Okay, if not, that is atoms, ions, and isotopes for you.